Hello students, welcome in your chapter number 3, matrices. In matrices students, today I explain our exercise 3, PMI related questions in the first one. Let A 0, 0, 1, 0 and I is the identity 1, 0, 0, 1. Then show that AI plus BA raised to N is equal to A and I plus NA raised to N minus 1 into BA. This numerical I will show that by the PMI. It means by the method of principal mathematical inductions. Yes, that is already known. So I go to our question. This proofing is taking that it is your principal P of N, which is AI BA raised to N, and show that A raised to N into I plus NA raised to N minus 1 into BA, and that should be our step 1. And step 1 you very well known, taking N is equal to 1. Yes, taking N is equal to 1, then what's your LHS? Pn, just apply P1, and that is your apply the LHS part, AI plus BA raised to N, but just I put it N is a 1. So AI plus BA raised to 1. Same as we going students, RHS. My RHS is a raised to Ni plus N into A raised to N minus 1 into BA. Just put it N is 1. So A raised to 1 into I 1, A raised to 1 minus 1 into BA. Just to check, A into I, anything, that is the same as here. AI plus A raised to 0 and N raised to 0 is a 1. So AI plus BA. Check, this both are same. Therefore, LHS is equal to RHS. It means, first, P1 is true. That should be your first step is easily done. After that I will going to now step number 2 students. Yes, it's very easy. Now students, after ending our first steps, we are going to second steps. Step 2, that also very easily known you. If PK is true and you just converting your P of N, that one, in the P of K. So AI plus BA raised to K, A raised to K into I plus K into A raised to K minus 1 into BA for every K belongs to natural. Now students, we are going step 3, which is to prove. And our two proof parts, we can apply P of K plus 1. So whenever you are K, you should be right K plus 1. So here AI plus BA raised to K plus 1. This side also same, A raised to K plus 1 into I, same K plus 1, A K plus 1 minus 1 and into BA, but that is a cancel, 1, 1. In short, we will telling here AI plus BA raised to K plus 1 is proving that A raised to K plus 1 I plus K plus 1 into A raised to K BA. That's our target. So now I start LHS. So my LHS, this one, AI plus BA raised to K plus 1. Both power 80. Just subtract the K and raised to 1. So AI plus BA raised to K and AI plus BA raised to 1. But that is your known. It is exactly your raised to K, your step 2. So I just put it A raised to K into I plus K, A raised to K minus 1 into BA. And other is same as AI plus BA, and declare by this step 2. Yes, from step 2. Now students, I will multiply this, that both, and second also both. So I start just a raised to k into I with ai plus ba, same as k with a raised to k minus 1 ba with also ai plus ba, and you just slowly multiply to each terms. So here this multiply, definitely here a raised to power 81, so it should be a raised to k plus 1 I into I square plus a raised to k into I with ba. Next one more, this term multiply with that, so here k ba and a raised to k minus 1, but here power 81, it is plus 1 into I, and last term k a raised to k minus 1 into ba with the ba, it means b square a square. And after that I will moving my last steps that we cover to your answers. So one more time I just read the our a 0010, that is 0010, because I will utilize a square and other term as it is. So first of all I will tell the a square, because that apply that a into a, which should be 0010 into 0010. You easily cover row with column multiply. So 0 plus 0, next 0 plus 0, 0 plus 0, and last also 0 plus 0. In short, it is student zero matrix. It means this data is gone. That remaining only I have continue my steps is raised to k plus 1 into I square become I, because identity into identity. Next a raised to k with I ba, and last k b a capital A and small a raised to k into I, and last one is 0. Now students, you will just finalize your answer I with any terms, it is the same functions. So your answer is coming that a raised to k plus 1 into I, this is identity related, any terms, it is only the functions. Here kb a raised to k of I, and here students you will take common a raised to kba, other are k plus 1. This answer is coming that yes. So a raised to k plus 1 into I plus here common taking a raised to k ba, other is k plus 1, and that is my purely RHS. Check that a raised to ai k plus 1 a raised to k ba. So therefore I will taking p of k plus 1 is true. So last ending these sums you just write down, therefore if pk is true, then p of k plus 1 is also true. And last write, therefore by p mi pn is true for every n belongs to natural. Pn means this pn, here true for every natural number. Now I will go to second questions, that also I will prove by the PMI property. Very interesting numerical, first, second and third. It is proved by PMI process. So if a given matrix A, question 2, if the A matrix all data have 1, then prove that A raised to n, which is 3 raised to n minus 1, 3 raised to n minus 1. Similarly, 3 raised to n minus 1, 3 raised to n minus 1, and for every natural number. So this is your Pn. Yes, here I just mentioned that's my target principle of mathematical induction wise Pn. So I go to just step 1, taking n is equal to 1. So what's your LHS? Your LHS is a Pn, P1, which is a raised to n, but a raised to 1 here. N put it 1. Yes, that's a raised to 1. It means a. Now RHS. Your RHS is a purely given 3 raised to n minus 1. 3 raised to n minus 1. You just put down n is a 1. Same as 3 raised to n minus 1. 3 raised to n minus 1, and apply your value, n is a 1. Definitely 1 minus 1 0. I mean 3 raised to 0. 3 raised to 0. That should be same. And n raised to 0 is 1. All data have indicate the a, and that is your LHS and RHS same. Therefore, I will write down my LHS part is equal to RHS part. So P1 is true. That is your P1 true. Now continue going to step 2, and that covered by our PK related. Yes, in the step 2, if PK is true, very easy. PK is true means just I show this P of n in the translate of k. So a raised to k, and other is a 3 raised to k minus 1. 3 raised to k minus 1. Same as 3 raised to k minus 1 for every k belongs to natural. And last, step 3, which is to prove P of k plus 1. Just here write down k with k plus 1. In short, what you get? K plus 1 and minus 1, only 3 raised to k each term. That's a target, students. 3 raised to k. And I will start now LHS. And this is your a raised to k. By mistake I not written. A raised to k is equal to that. In place of k, k plus 1. My LHS is a raised to k plus 1. A raised to k into a raised to 1. And a raised to k, your step 2. So 3 raised to k minus 1. All have same data. 3 raised to k minus 1. And 3 raised to k minus 1. And into a become. A is known. All are element 1 1, and that you apply the product rule between first with second. Just simple as this that, and apply the product rule. Definitely they cover to your RHS part. So see that first with that, second with that, and third with that. So your RHS part is moving 3 raised to k minus 1 plus 3 raised to k minus 1 plus 3 raised to k minus 1. At a total, all elements are same. 3 raised to k minus 1. Same as. Similarly. And you write down total 9 times. Because all are same cases. 3 raised to k minus 1. Similarly, we going ahead. 3 raised to k minus 1, and last column also same, because all are 1 1 1. 3 raised to k minus 1, and here I ending 3 raised to k minus 1, 3 raised to k minus 1, and 3 raised to k minus 1, and definitely they will cover 3 times 3 raised to k minus 1, 3 times 3 raised to k minus 1. And here base same, power it added, same as 3 times 3 raised to k minus 1, 3 times 3 raised to k minus 1, same as 3 raised to 3 times k minus 1. And that is your base same. You can apply power addition. Definitely it is 3 raised to k. Each have 3 raised to k. And that is your what? RHS. Check that. Definitely cover. So my numerical is done here, but just I write down, therefore P of k plus 1 is true. So what you finally prove? So therefore if Pk is true, then P of k plus 1 is also true. And now moving to my last line. Yes, that is your by PMI, principle of mathematical induction. Pn is true for every n belongs to natural number. Now continue. Question number third. Third also same going. By PMI is proving where n is for every positive integer. For n, every positive integer, if a become 3 1 minus 4 minus 1 minus 4 minus 1, then prove that. What to prove that? Yes, a raised to n, which is 1 plus 2n and minus 4n and 1 minus 2n, 1 plus 2n and minus 4n and 1 minus 2n. Very easy. This is your target. You will write down that is a P of n. And step 1, if n is equal to 1, so my LHS become Pn, just converting it P1. And my LHS part is what? A raised to n, a raised to 1, 3 1 minus 4 minus 1. Now RHS 1 plus 2n and minus 4n 1 minus 2n and apply 1. So it is 1 plus 2 with 1, 4 with 1, and you will just check it is 3, 1, minus 4, minus 1, and it is same as it is A. Therefore LHS is equal to RHS. It means P1 is true. First step happily done here. Now moving to our second steps. Step 2. So in the step 2, very easily, if Pk is true, so you should be this P of n write down in the k terms. So a raised to k, and here 1 plus 2k, k minus 4k and 1 minus 2k for any what? Z positive integers. And step 3, which is to prove P of k plus 1, just apply a raised to k plus 1 and k just write in the place of that plus 1. So 1 plus 2 k plus 1, k plus 1 minus 4 with k plus 1 same as k plus 1. You just expand total. Here 2k plus 3, k plus 1, here minus 4k minus 4, and here 1 minus 2k minus 2. In short, what you get? 2k plus 3, k plus 1, next minus 4k minus 4, and last minus 2k minus 1 means minus 2k plus minus minus 1. That's the answer. Now we start my LHS. It's very easy. A raised to k with a raised to 1. A raised to k is that step 2 from, and a also I know from that this is 1. So 1 plus 2k, k minus 4k and 1 minus 2k, and another RA is that 3 1 minus 4 minus 1, and start your process row with the column multiplications. And I hope you easily understood that type the way. So your product value is that 1 plus 2k minus 4k. Similarly, k 1 minus 2k with bracket. It is a first column fitting here. Now second same as 1 plus 2k minus 4k and last here this row clearly. Now secondly k and 1 minus 2k with last. So first of all 3 1 3 1, second minus 4 minus 1 minus 4 minus 1. So my answer is clearly 3 plus 6k minus 4k, 3k plus 1 minus 2k, and last minus 4 minus 8k plus 4k, and minus 4k minus 1 plus 2k, and that is your cover to 3 plus 2k. Check, same answer. Here k plus 1, again same. Here minus 4k minus 4, and last minus 1 minus 2k. That's your RHS. Yes, here I will show my question answer is done. So what you write? P of k plus 1 is true. Therefore, if pk is true, then p of k plus 1 is true. So last write down by PMI. Pn is true for every n belongs to Z positive. Yes, here this question is done happily. Now question number 4. It's very interesting questions and very easy. I slowly explain that. Yes, students, in the question 4, if A and B are symmetric, if A and B are symmetric matrix, then prove that, show that. What is show? AB minus BA, AB minus BA is a skew symmetric, is a skew symmetric. So very easy, this definition you know. If A and B are symmetric, so A transpose is A, B transpose is B. That's our definitions. Now we prove that AB minus BA is a skew. So we taking its transpose and take the transpose property. Check what you get. It is AB transpose minus BA transpose, and that should be B transpose A transpose. Here A transpose B transpose, and value put it. B transpose is a B. So here BA, that is AB, and just common take minus outside. So AB minus BA. That AB minus BA is same as, but minus carry outside. So students, your target achieved in the minus weighted transpose initial two. So it is a skew. Therefore, AB minus BA is skew symmetric matrix. Very easily done here. Now continue question number 5. 5 also very easy and very simple. That yes, if show that, just first question right? Show that B dash AB is symmetric or skew symmetric if conditions given: A is symmetric or skew symmetric. Students, these are the half portions separate calculate, and these are the half portions separate calculate. So very easy. First I taking A symmetric. If A is symmetric, so my definition is A transpose definitely A. Now that's my target. B dash into A dash, here dash right? It is transpose and dash are same. Now these are symmetric proofing, so B dash AB, I will take the dash, this and that I separate by the rule AB transpose into B transpose the transpose, this same, but B transpose the transpose is B. Now again formula, B dash, A dash, B. But A dash I know, which is A from given. So it check, these are the same coming. B dash, AB dash is the initial same. They're not changing in the sign. If you sign changing, then yes, it is the symmetric and skew symmetric. So you will write down B dash AB, not sign change, therefore is a symmetric matrix. And if you sign change related obtain, then it is shown to skew symmetric. Now I will go to second portions. The second part, very easy. If A is skew symmetric matrix, so definitely your A transpose is a minus 8A. That will you apply in same. So now B dash AB dash, both subtract. It is AB dash of B dash D dash. Now here same AB dash, but B dash to dash is a B, because the property transpose of transpose 2 times, it's the same. Here apply same, B dash A dash with B, and B dash, here A dash is what? Minus A, and B same, just carry minus outside, it is B dash AB, and that's your initial to transpose coming now here, outsider minus. In compare of first, it is totally opposites. Therefore we will write B dash AB is skew symmetric matrix. And here this question also, students, done. Now we going ahead, question number 6, and 6 also very easy numericals. Find x, y, z if the given matrix. Question 6, find x, y, z if a given A dash into A is equal to I, and A matrix 0xx to y minus y, z minus z, z. Very easily I just apply the value of A dash into A is equal to I forming. Just make matrix multiplications. So this I apply from given A dash into A, which is I. A dash I have this transpose row changing in the column. So definitely you will cover to your answers 0 to yz, x, y minus z, x minus yz, and A as it is 0 to yz, x, y minus z, x minus yz, and I is also known 1 0 0 0 1 0 0 0 1. So this row, that column, just matrix multiply. So 0 with 0, x square. Now this row and this column, 0 here yx minus xy, next 0 minus zx plus zx, in short 0. Now row to second column, now this row, this column 0, next xy minus xy. Similarly 4y square, next y square plus y square, it is 6y square, and here 2xy 2yz minus zy, this also cancel, and last row to last column now 0 minus xz plus xz, now 2yz minus yz, this cancel also, and last of the z square plus z square, it should be same. So finally what you get? You getting only, students, here 2x square 0 0, now 0 6y square 0, 4 find 6y square 0, and last 0 0, it is the 3z square, and is equal to comparison. by the equal matrix. So by equal matrix, I just compare it. 2x square equal to 1, x square is half, x become plus or minus 1 by root 2. Similarly, students, I will go to second part's comparison to that. So 6y square is equal to 1, y square is 1 by 6, y is plus or minus 1 by root 6. And lastly, third one also compare to that. 3z square is equal to 1, and that also I just highlight. Z square is a 1 by 3, z become plus or minus 1 by root 3. And that is, students, here either using that x, y and z is happily and easily done. Yes, students, this video and this part I will stop here, and further explanation for exercise 3 I will explain in the next part. Bye bye.